All right, here we go. I can shoot an arrow straight up to reach the top of a 25-meter tall building. And here I've cheated a little bit, and I've actually drawn my 25-meter building already. And I want to know, what can I figure out from this? So one way is to just figure out, well, what sorts of, what do I know already? I'm going to write that right away. I'm going to write g is minus 10 meters per second squared. And then I'm going to think about the various kinematics equations that I have at my disposal and think about what can I maybe do with them. So one of the things that occurs to me is I don't know what the initial speed here is, and it would be nice to figure out what that speed was, right? So I do know that the final speed, at least in this case, is going to be 0 if I think of that as the speed at the top of the building. And then I can ask myself, well, what's the initial speed that will allow that to be the case? So, well, let me just write a few things down and see what I can do. So I know that if I take, for example, an initial plus a final velocity, divide by 2 and multiply by time, I should be able to get the distance that I've traveled. Now in this case, I know the distance is 25. I know that this v over here, this final velocity, I can put the subscript there, is 0. And I see that I don't know the time and I don't know the initial velocity. So I have one equation, but I have two unknowns. So that means that I'm not really at a point where I can make a lot of progress yet. So I'm going to say, well, all right, let me figure out what else can I do. Well, I know that if I take, let's say, the acceleration times the time, right, that'll lead to a change in velocity. So if I take the initial velocity and I add it to the change in velocity, that will give me the final velocity. So I could write that, let's say, this way. And when I take a look at this one, I can say, well, all right, VF is something that I know. It's 0 at the top of the building. And here I have this little g I know, and here is a t and a vi, and I don't know those two. But this time I have a second equation with the same two unknown variables. So the same two unknown variables are this vi I don't know, and this t that I don't know. But I've got two equations. That means by substitution, I should be able to figure this out. So I can go ahead, and now I feel like I have some confidence to do this. So I'm going to say, well, all right, let me figure out, for example, I don't really want the time so much as I want the initial velocity. How about? So I can take this second equation and I can solve for the time. Well, that VF is 0, so this must be the same as minus VI over little g. Okay, so I've got a time. Now I can substitute that into the one up above. And if I do that, I have VI plus VF over 2 times minus VI over little g, and that's supposedly equal to the distance traveled. Now this looks a little bit annoying. I'm trying to figure out VI, but now at least I feel like I've got one equation with one unknown. I know this d is 25. I know the g. I know the VF is 0, right? The final velocity up at the top of the building. And so now I feel like I can make a little bit of progress. So I'm going to take this down here, and I'm going to realize that if I do VI times VI, I get minus VI squared over 2, and also over g, so I can write the little g down there, and that's going to equal d, okay, the distance that I go. And now I want to solve for VI, so I can now say that VI squared is going to be minus 2gd, like that. And the minus sign doesn't bother me because I already up here I used minus 10 meters per second squared for little g, so I know I'm going to be able to figure this out. So finally, if I wanted to stick with just these letters for now, I have VI is going to equal to square root of minus 2gd. And in my specific case here, that's going to equal 20 times 25 under the square root, and I know I'm using standard units. I know my result is going to be in meters per second. So I can either do this on my calculator. I know the square root of 25 is 5. The square root of 20 must be, 4.5 or something. So this has got to be something like 5 times 4.5. So this must be, 20, maybe 22 or 23. So I'll say something like 22.5 approximately. And this is going to be meters per second. So this is going to be the initial speed of my arrow. Okay. All right, now it took almost 5 minutes to do that, but hopefully if you're doing that on your own, it doesn't take quite that long. How far will the arrow travel if we shoot it horizontally while pulling the bow in the same way? The arrow starts 1.45 meters above the ground. Okay, So, all right, if I now fire my arrow horizontally, okay, so part B here. Is that part B? Actually, let's see. Nope, that's part A. They just want to... I had to do all this preliminary work just to figure out an initial velocity so I can do part A. Okay, so this is a pretty tricky problem. All right, so let's try to figure this out. Now I fire the arrow horizontally. Okay, and it starts at a height of 1.45 meters, and I need to know how far it can go. So I'm going to put this VI, which I think is about, I think this is roughly speaking, about 22.5 meters, and you can get the more exact value if you want later. And I ask myself, well, if the only way to do this problem is really to imagine that the error isn't affecting the arrow, and I want to know how much time does it take for the thing to hit the ground. Well, how much time does it take to hit the ground? Well, if I go up here and I look at my various equations, I say, well, I could try using these again. In fact, if I look at the VI plus G, let's see, VF, well, I don't know the final velocity either. This one looks to me like one, again, I might have to try another equation. Well, another equation that can be derived from the ones above is that the height of an object over time can be written with this kinematics equation. Again, you should make sure you know how to derive these things every now and then. And if I look at this one, I think that this one might be useful. Here now the VI is VI in the y direction, right? It's going the downward direction. So this thing is going to start out as 0, okay, when I launch my arrow. The h minus hi, that's going to give me the, or vice versa, it's going to be the 1.45 meters. And since the h is really 0 after a certain period of time when it hits the ground, the h minus hi will be a negative number, and that'll allow me to again get something like this. So I'll get minus 1.45 meters is a half g t squared. And now from this, I should be able to figure out. So 2 times 1.45, that's going to be 2.9. Divided, I'm going to get a t squared, which will be 2 times 1.45 over 10 under the square root, right? So I'm going to get 2.9, 0.29, I guess, okay, seconds. Now, if I think how big is that going to be, 0.29 will be about, let's see, 0.5, 0.6, roughly 0.55, 0.55 roughly seconds. Anyway, the exact thing I can get later, what really matters is that I feel like I know how much time passes. Okay, now finally, I've got this time, and they're asking how far will the arrow travel if you shoot it horizontally, starts 1.5. Now I have two numbers that I can use. I have this velocity here, this VI, that's the initial velocity of the arrow when I fire it from my bow, and this amount of time it will take to hit the ground when it just falls down. So I can now say that the horizontal distance, right? So horizontal distance, so let's go like this, dx, horizontal distance is going to be the velocity, my initial velocity, times the time, okay? Velocity times time. Now don't get too confused here. The velocity here that I'm talking about is the velocity that at this point is horizontal, and that doesn't change as it moves. Now that's a very sort of strange thing to think about, but keep that in mind. It doesn't change as it moves to the right. So I can now get a specific number if I want, like 22.5 times about 0.55, and that's going to be an answer in meters. So I'm going to get approximately whatever that is, about, what is that going to be? A little more than half of 22, so 11, let's just say about 12 meters, something like that. So I should be able to launch it about 12 meters horizontally. Now I was able to launch it 25 meters vertically, because I was able to shoot it straight up in the air. When I shoot it horizontally, it didn't have much time to go before it hit the ground, so it doesn't go quite as far to the right, just because the ground gets in the way. All right, we've found almost 10 minutes of this video. Can we get any further? Where do you need to put the target to a target that's 1.5 meters above the ground in order to hit it? If you aim 30, okay, hang on a minute. We're gonna stop this video for now, and we're gonna come back to it and look at the part 2 in just a moment.